every action. Hi, I'm Ms. Thorson. I'm a middle school science teacher, and every day that my students aren't in school because of the novel coronavirus, COVID-19, I'm making a short science video to share. Today, I want to talk about Newton's third law of motion. For every action, there is an equal but opposite reaction. Now, this is a law that you probably experience in your everyday life, and you've probably heard somebody say that for every action, there's a reaction, or an equal and opposite reaction, or an equal reaction, or something like that, even if you don't know exactly what it means. But it's actually a really easy concept to understand. And I want to start with a simple demonstration that you can do with your own body at home. We're going to start by putting up our left hands. Don't touch your face, especially if you haven't washed your hands. Wash your hands. Put your hand up in front of you like this, left hand up, and then put your right hand up and they're going to touch. Now, with your left hand, you're going to push against your right hand. And your right hand is only supposed to stay still. So don't push with your right hand, just hold it in place. So that right hand stays right there, it doesn't move. The left hand is going to come in and push. Ready? Okay, so try that. Now, what do you notice in your arms? Do you notice that both arms have to work? That muscles in both arms have to work? That's because when you push this way, there are only two things that can happen. Either the force coming this way is going to push this hand out, which I told you not to do, or this hand is going to have an equal and opposite reaction going in this direction so that this hand doesn't push it out of the way. So if you're holding this still, when you push with your left hand, the right hand has to push back just as hard. It's really that simple. Now, there are some tools we can use to measure force, and that's a way of measuring an equal and opposite reaction. I want to show those to you. I realize I left them in the other room. I'm going to pause and go grab them and come right back. I'm back. Okay. It's late. I've been chasing all over the house trying to find good lighting to take this video, so I ended up leaving my spring scale somewhere they shouldn't have been. We're going to be using something called a spring balance, or a spring scale, and it's just a really simple piece of equipment. If I can get the box open. There we go. It looks like this. I brought two of them home from school with me because I knew I was going to be making these videos. I didn't ask permission, but don't worry, Dr. Floyd Cooper, I promise I will bring them back with me when we finally come back to school. This is the spring scale. It's called a spring scale because it has, if I can get this to focus properly, a spring in the back. And you can see when I pull down on this hook, the spring stretches. So that's just a spring scale. All it is just a spring with a hook on the end. And on the front, we have measurements, and it is in grams and newtons. Grams are a measure of mass. Newtons are a measure of force. So the newtons tell us how hard are we pulling on the spring. Now, as you can see, I can pull 10 newtons with just one finger. 10 newtons is not a lot of force. There are much bigger spring scales. People use them on farms sometimes. They'll have very big ones where they can put, they can wrap like a baby animal up in a blanket and then hook the blanket onto the scale and weigh the baby animal. You'll see scales like this any place where people are buying things they want to weigh really quickly. They're convenient. They don't care about the weather. They don't need batteries. They're very lightweight. They're simple to make, so they're inexpensive. And if you're not throwing them across the room, they're pretty hard to break. So I have two of them. I brought two home. They were in identical boxes, but then they're actually different. So one of the Shineco spring balances got put into an O House box. I'm going to go ahead and blame my 8th graders for that. Doesn't matter. The only difference is that this one only goes to, let's get it over here, only goes to 5 newtons. It doesn't go all the way to 10. So when you look at the demonstration I'm about to do, you want to make sure you understand that just because this one went all the way down doesn't mean that it's at 10. This one's only going to 5. So when I pull this one all the way down, it only goes to 5. But when I pull this one down, it goes to 10. And I will make sure I make that clear in the demo. So I'm going to pause and set up the demo, and we'll watch that, and then we'll be done. Okay, so we have our spring scales here set up opposite each other for an equal and opposite reaction. I'm going to hook the 2 hooks of the spring scales together so that, if I can get them to stay together, so that they pull on each other. And then I'm going to take the one that's on my right here, and I'm just going to hold it down. I'm not going to pull on it or anything. I'm just going to hold it down with my hand. So stick my finger right there, and we're just going to hold that still. You can see my hand is flat on the table. It's not going to move. I'm going to take this one with my left hand, and I'm going to pull on it until we get to 5 newtons on this scale. So I'm at 5 newtons. We have pulled the spring down far enough that I am exerting a force of 5 newtons with my left hand. And you can see it's not very much. I'm just holding it with one finger. But if you look at the other scale, what does it say? It also says 5 newtons. Now these are slightly different scales. We mentioned that before. So this one on my right hand only goes to 5 newtons, but you notice it's the same. So if I pull on this, what if I only do 1 newton? So we're just going to pull down to 1 newton. 1 newton and 1 newton. Okay, 2, still 2. 3, all the way down. If I had 2 10 newton scales instead of 1 newton, 1 5 and 1 10, then I would be able to do this all the way to 10. Every time they're going to be the same, because when I pull on the scale on my left, the scale on my right has to exert the same force in the opposite direction. And that is Newton's third law. See you next time.